Hello and welcome you all. Today we will do some more questions based on quadratic equation which I've asked in previous year board examination. So our first question for today is, if minus 5 is a root of the quadratic equation 2x square plus px minus 15 is equal to 0, and the quadratic equation p into x square plus k equal to 0 has equal roots, then find the value of k. So according to the question, if minus 5 is the root of quadratic equation, so on putting minus 5 in the given quadratic equation, which is 2x square plus px minus 15 equal to 0. So from here we get minus 5 square equal to 25, and 25 into 2 is 50, and then plus into minus is minus 5p, and minus 15 equal to 0. So from here we get 5p is equal to 35 and p is equal to 7. Therefore student, when we put this value of p in the quadratic equation, p into x square plus k, which is equal to 0. So our quadratic equation will become 7 into x square plus x plus k equal to 0. And from here we get 7x square plus 7x plus k equal to 0. And now as per question, this equation has equal roots. So we know that if roots are equal, then discriminant is equal to 0. Therefore b square minus 4ac is equal to 0. And when we put the value of b, which is 7 square minus 4 into value of a, which is coefficient of x square, that is 7. So minus 4 into 7 into k equal to 0. So from here we get 49 minus 28k equal to 0, and k is equal to 49 upon 28. Now on solving this fraction, we get k is equal to 7 upon 4. And now our second question for today is, if the ratio of the roots of the equation lx square plus nx plus n equal to 0 is p is to q, then prove that square root of p upon q plus square root of q upon p plus square root of n upon l equal to 0. And now by applying quadratic formula, which is equal to x is equal to minus b plus minus root d upon 2a, and where d is equal to b square minus 4ac. So roots of the equation lx square plus nx plus n equal to 0 are x is equal to minus n plus square root of n square minus 4nl upon 2l, and x is equal to minus n minus of square root of n square minus 4nl upon 2l. And we know according to our question that the ratio of the roots is p upon q. So we can write it as p upon q equal to minus n plus square root of n square minus 4nl upon minus n minus square root of n square minus 4nl, because on taking the fraction 2l and 2l will get cancelled out. And now by taking the LHS, which is square root of p upon q plus square root of q upon p plus square root of n upon l, when we substitute the value of p upon q in LHS, we get square root of minus n plus square root of n square minus 4nl upon minus n minus square root of n square minus 4nl plus, and now q upon p, which is the reciprocal of p upon q. So from here we get square root of q upon p, which is equal to square root of minus n minus square root of n square minus 4nl upon minus n plus square root of n square minus 4nl, and then plus square root of n upon l. And now by taking the LCM, we know that square root will get cancelled out. So we get minus n plus square root of n square minus 4nl, and then minus n minus of square root of n square minus 4nl. So from here we can clearly see that square root of n square minus 4nl and minus of square root of n square minus 4nl will get cancelled out. So in numerator we get minus of 2n, and in denominator we know that root x into root y is root xy. So from here we get minus n into minus l is equal to n square, and then minus square root of n square minus 4nl into square root of n square minus 4nl. So we get minus n square plus 4nl. So from here we can see that n square minus n square will get cancelled out. And now from here we get minus 2n upon 2 square root of nl plus square root of n upon l. So from here 2 and 2 will get cancelled out, and we get minus n upon square root of n square root of l plus square root of n upon l. And now on rationalizing the denominator, we can write it as minus n root n upon n root l plus root n upon l. So from here you can clearly see that minus root n upon l plus square root of n upon l will get cancelled out, and this is equal to 0. So hence proved. Now our third question for today is, show that if the roots of the following quadratic equation are equal, then AD is equal to BC, such that x square into a square plus b square plus 2 into AC plus BD into x plus c square plus d square equal to 0. Now as per question, roots are equal. So we know if roots are equal, then determinant is equal to 0, and the value of determinant is equal to b square minus 4ac, which is equal to 0. So 2 into AC plus BD whole square minus 4 into a, and the value of a is coefficient of x square, which is a square plus b square. So minus 4 into a square plus b square and the value of constant which is c square plus d square, and this is equal to 0. So on expanding 2 into ac plus bd whole square, which is equal to 4 into a square c square plus 4 into b square d square plus 8 ac bd, and then minus 4 into a square c square and minus 4 into a square d square, and then minus 4 into b square c square and minus 4 into b square d square, which is equal to 0. So from here you can clearly see that 4a square c square and minus 4a square c square will get cancelled out. Similarly 4b square d square and minus 4b square d square will also get cancelled out. So from here we get 8 acbd minus 4a square d square minus 4 b square c square will be equal to 0. So from here when we take minus 4 as common, in bracket we get a square d square plus b square c square minus 2ac bd, which is equal to 0. So using the identity we can write it as minus 4 ad minus bc whole square. So from here we get ad minus bc equal to 0. So from here we get ad is equal to bc, and hence we have proved our result. So this is the end of this video. Thank you so much. Have a great day ahead.